Okay, in this video lesson, we're going to look at a trigonometry review. So we're going to go way back. Back in the day, you were first introduced to a triangle, where each of the three edges was called a side. So we had side, side, side. Then eventually we looked at a little more specific type of triangle, a triangle that had a right angle in it. And because it had a right angle, we were looking at a right triangle. And so the three edges weren't generically called sides. Specifically, the two edges that made up the right angle, those were named legs, and the side opposite the right angle was the hypotenuse. So we transitioned from just generically side, side, side to leg, leg, hypotenuse. Then if we took the same triangle and we began to focus in on the two angles in it, specifically the two acute angles. Because it is a right triangle, the other two angles by default would have to be acute. So if we were just considering standing at this particular acute angle, then the leg that is right next to it would be called adjacent, while the other leg that's on the other side would be considered opposite. So we now transition from generically side, side, side to a little bit more specifically leg, leg, hypotenuse, and now ultimately each side has its own unique name, opposite, adjacent, hypotenuse. But we need to consider that the adjacent and the opposite is named based upon the acute angle. What I mean is this: if we were standing at this acute angle, then this leg is now adjacent, while the other leg is opposite. So the name of the two legs, opposite and adjacent, is dependent upon which of the two acute angles you're referencing. So what we now have are three unique words, opposite, adjacent, and hypotenuse, to identify the three specific sides of a right triangle. So what trigonometry does is says, let's just take two of these three sides and create a ratio. So if I took two sides, let's just say the opposite and the hypotenuse, we've created a ratio. Again, these are not just names of sides, but they represent the lengths of each of these sides. So we're actually creating, in other words, a fraction. So I can try two other words, that's adjacent and hypotenuse. Or if I chose, say, opposite and adjacent, I have three unique ratios. There's actually three more because they do represent numbers. If this was a 5 and this was a 7, if the opposite was 5 and the hypotenuse was 7, if I reciprocated them, 7 over 5 is a totally different ratio. So that's what I'll set up, are the three different reciprocals. So hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. So what we've created just using these three sides are 6 different ratios. And so what they've done with trigonometry is, instead of just always referring to these ratios using these three words, they're going to basically create a nickname. So the nickname for opposite over hypotenuse, they've named it sine. So anytime we use the word sine, it's referring to the ratio of the opposite side to the hypotenuse. So all 6 ratios will have a unique word associated with it. So adjacent over hypotenuse is named cosine. Opposite over adjacent, tangent. Hypotenuse over opposite, so the reciprocal of sine, cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. So now we have these six unique words. And these are considered our trigonometric functions. Each of these 6 red words actually relate to just a ratio of two sides from a right triangle. And what they've then done is take these red words and come up with a 3-letter abbreviation. So the abbreviation for sine is SIN. Now mind you, that's not pronounced sin. It is still just an abbreviation for the word sine. For cosine, COS, the abbreviation for cosine. Tangent, TAN. For cosecant, one might think let's just use the first three letters that we're doing over here. But if we did that, it would be the same as cosine. So what they've done is, because it's a three-syllable word, co-see-can't, they've chosen the first letter of each of the three syllables, CSC. Secant, SEC, and cotangent, COT. So now we have our 6 trigonometric functions, which are the red words, and their corresponding ratio. Those are our purple, green, and gold words. And so now the expectation is that you recall this. So most teachers will bring up a mnemonic device to help you remember this. The mnemonic device is SOHCAHTOA. There's the SO, S-O-H. S stands for sine, is the ratio of opposite to hypotenuse. Ka, cosine, adjacent to hypotenuse. And TOA, SOHCAHTOA. T for tangent is the ratio of opposite to adjacent. So oftentimes in a trigonometry class, you often hear the word SOHCAHTOA to help one recall the actual trig function and the corresponding ratio. And if you look at them closely, this actually looks like the word O, the word A. So the word O in English is spelled O-H. The word in English, the word A in English is spelled A-H. So to bring some familiarity to this new information. So if I put this all together, what this entire video lesson is the 6 trigonometric functions and the corresponding ratios. The 6 trigonometric functions were those red words. So the trig function is sine, and the corresponding ratio is opposite to hypotenuse. You notice here that I've actually included the theta symbol to illustrate that the angle is part of this entire situation here. If you recall, we had the little man pointing to an acute angle. Once we were at an acute angle, then we identified 2 specific sides. So my 6 trigonometric functions with the corresponding ratios has to include some sort of symbol to represent not just an angle, but the acute angle in our right triangle. So we continue. Cosine of theta equals the ratio of adjacent to hypotenuse. Tangent of theta is the ratio of opposite to adjacent. Cosecant of theta, hypotenuse over opposite. Secant of theta, hypotenuse over adjacent. And cotangent of theta is the ratio of adjacent to opposite. So these are your 6 trigonometric functions with the corresponding ratios. Now there's one other way you might see this list. The list may not include the theta symbol, but some other symbol that still represents the acute angle. So I've substituted theta for the little angle symbol. So again, these are your 6 trigonometric functions with the corresponding ratios. So next, we'll look at actually applying some of this. So here we want to look at determining all of the trigonometric functions, and all you're going to be given is just one of them. So it says, use the given information to determine the remaining trigonometric functions. So if all I tell you, cosine of theta is 5 over 13. In order to determine all 6 trigonometric functions and their ratios, we needed those 3 values, the value for the opposite, the adjacent, and the hypotenuse. So we were given cosine. That means cosine is the ratio of adjacent to hypotenuse. So what we were given was, we were told that 5 therefore represents the adjacent leg, and 13 represents the hypotenuse. So if I drew a picture to help us visualize what's going on here. If you recall, the first thing I have to identify is the acute angle we are referencing. So I'm standing at that angle theta, which means then the 5 will be placed on this leg and the 13's on my hypotenuse. So all I'm missing is my opposite side. Because we're working in a right triangle, we'll use Pythagorean's theorem. So in this case, c squared minus a squared equals b squared. Notice I didn't start with just a squared plus b squared equals c squared. I've chosen this form of it because of what I'm working with. The largest leg, c, the hypotenuse, largest side, c, the hypotenuse, and one of the legs. So let's substitute. Let's simplify each of these exponents. Let's simplify further by combining like terms, and now we'll solve by taking the square root on both sides. So therefore, we're left with b is 12, which means then the opposite side, the side we were missing, is now 12. So there's the 12. Now we have all three values to identify the 6 trigonometric functions. So here we go. Sine is opposite over hypotenuse. Well, the opposite is 12, and the hypotenuse is 13. There's sine of theta. Cosine was already given to us. Tangent is opposite over adjacent, so therefore, tangent of theta, 12 over 5. The other three are just its reciprocals. So cosecant theta, hypotenuse over opposite, 13 over 12. Secant theta, hypotenuse over adjacent, so therefore that's 13 over 5. And finally, cotan, adjacent over opposite, therefore 5 over 13. So we're beginning to apply the 6 trigonometric functions that we created earlier. Now we're applying it to help us determine all the remaining just given 1. And hopefully you notice that really all you're doing is applying Pythagorean's theorem. So hopefully this will help.